This week, Shanghai-based AI company AGIBot demonstrated its G2 robot working a real production shift at the Longcheer smart device factory in Nanchang. This isn't a highly edited lab demo, it's the world's first large-scale industrial implementation of embodied AI systems within core production workflows in consumer electronics manufacturing. Here is why this matters for the timeline of human replacement. Let's break down what makes this work. The AGIBot G2 utilizes a 3-degree of freedom waist and a cross-wrist force control arm equipped with high-precision torque sensors. Combined with an embodied intelligence architecture that perceives its surroundings and makes decisions, this allows the robot to feel when something is off and correct itself on the fly, without the need for manual adjustments to force control parameters. In human terms, that's like a worker noticing a misaligned tablet on a moving conveyor belt, adjusting their grip, and seamlessly inserting it into a test fixture. The robot communicates in real time with the factory's manufacturing execution system, MES software. It completes each operation in just 18 to 20 seconds, allowing it to process 310 units per hour. Now for the reality check. Notice the unedited 8-hour marathon livestream format AGIBot used. That's proof of continuous operation. No cuts, no replays, just a machine doing its job. The press release says it achieved a task success rate above 99.5%, and the engineering reality backs that up with over 140 cumulative stable hours logged on the actual line. However, what we're not seeing is the immense data pipeline required to make this autonomous. According to Yao Qing, president of AGIBot's Embodied business unit, the industry currently has very little data. He admits they may need on the order of 100 million hours of real-world and simulation data to reach a ChatGPT moment for physical robots. Behind the scenes, China is relying on massive 4,000 square meter data collection factories in Shanghai, where young human operators remotely teleoperate robots through thousands of everyday tasks just to generate the scarce training data needed. Let's talk about what this means for actual jobs. The specific role being disrupted here is a 3C: computer, communication, consumer electronics, material handling, and assembly worker. Run the math. A single AGIBot G2 model processing 310 units per hour is actively matching the output of 2 human stations. If one robot replaces 2 human workers per shift and can run continuously day and night, the replacement economics heavily favor the machine. Furthermore, flexibility has always been the bottleneck in 3C manufacturing due to short product life cycles. The G2 shatters that constraint. It features 95% equipment reusability and can be retooled for a completely new tablet model in under 4 hours of retraining, with scene calibration taking a mere 15 minutes. At that rate, you're looking at replacement economics that work for major smart manufacturing platforms today, with Longcheer planning to scale up to 100 units by the third quarter of 2026. Let's review the Robotshift Scorecard: technical maturity, production, economic viability, highly viable, 1 unit matches 2 human stations. Hype versus reality, 8 out of 10, livestream proof, but still bottlenecked by 100 million hours of missing training data, estimated deployment 2026-2027, deployment stage, pilot to production. So here's where we are. AGIBot demonstrated a continuous 8-hour production shift on a live assembly line, which moves us from the laboratory concept threshold to actual industrial productivity. We analysed how its force control arm and embodied AI allow it to handle real-world deviations, and fact-checked the hype against the engineering reality that millions of hours of teleoperated data are still required to perfect these systems. The tech is mature enough to replace 2 human workers at a time, and the economics are undeniably viable for flexible deployment. That's it for this shift. Subscribe and join me next time as we track the economic transition from humans to robots. Signing off.